All right, so it says compare the functions below, and then I got three functions, and they're all graphed. And then there's a series of statements that I have to mark as true. So let's just read the first one. It says, over the interval 2, 3, the average rate of change for G is lower than both F or H. And that is, so when they talk about the rate of change, they're talking about the slope. So I'm going to say that's not true because F from 2 to 3 is very steep. From here to here, this is very steep. And then H is very steep from here to here. So, and G is just steady, it's just constant. So that one I'm going to say is not true. The next one says, when X is greater than 4, the value of F exceeds the values of G and H. Yeah, F is higher for sure than G and H. In other words, H doesn't reach when X is greater than 4. Yeah, because this is growing much faster. In other words, if I look at, well, X equals 5, my H value is right here. X equals 5, my G value is right here, but F is going to be way up here off the chart. So that one is actually true. Let's go to the next one. As X increases over the interval from 0 to infinity, the rate of change in G eventually exceeds the rate of change for both F and H. No, F and H, their rate of change increases. It gets steeper and steeper, right? So the more it goes straight up and down, the steeper the increase, the greater the increase on the rate of change, where G is at a slope for the whole thing. It's a constant rate of change, so it'll never do that. So that's not true. The quantity increasing exponentially eventually exceeds the quantity growing quadratically or linearly. Yeah, because this function f is the exponential, and it grows much faster than the quadratic or the linear function. So that one is true. And I'll zoom out so you guys can write this all down in a second. Well, I can probably zoom out now. It says, as x increases over the interval 0 to positive infinity, the rate of change for f eventually exceeds the rate of change for both g and h. Yeah, that's basically what we've been saying all along. It's just another way to word the last statement. Then it says, when x equals 8, h exceeds the values of both f of x and g of x. No. No. You can find that out by plugging it into the calculator, but if I look, my g of x goes, it will always be higher than h. F will always be higher than h, especially at x equals 8. So that one's not true. I'll try to zoom in a little bit. I wish this allowed me to just zoom in. I'll leave that part up. You guys got the graph and all that stuff? So just write down the correct answers. I'll leave that up there first.